its job is also is to segment the data. It uses sequence numbers to do this. And it also has an interesting thing to use between communication, which is called port numbers. Now, each one of these things has its own lesson to teach. This means if the traffic is going to not be guaranteed. It means I'm just going to send the traffic down the wire, and I don't really care if it gets there or not. It's best effort. I mean, I want it to get there, but I'm not going to make sure it does get there. TCP is a method of being guaranteeing traffic and making sure that my traffic is being used, being delivered. And in order for me to get that guarantee, guess what? I'm going to use sequence numbers to make sure that I'm getting the proper data back and make sure that my data is being sent. Let's see how that works real quick. If I send a piece of data over to PC1, now remember, sequence numbers and TCP are TCP uses sequence numbers to make sure we have guaranteed communication, which means if you're using TCP, you are expecting reliable transmission between both of these devices. PC1 sends a piece of data over. Here's my data. Comes over here to PC2. Attached to this data, we'll have a sequence number. Let's say a sequence number of 1. PC2 will come back and say, look, I have this data. I got it. He's going to send what is called an acknowledgement. And with that acknowledgement, he's going to send a sequence number of 2. That sequence number of 2 means to PC that means to PC1. When PC1 gets this acknowledgement with the sequence number of 2, he knows PC2 is expecting sequence number of 2. If PC2 sends this acknowledgement back with a sequence number of 1, it's telling PC that he's expecting a sequence number of 1. And PC1 knows that, well, if you're expecting 1 and I already sent 1, I need to resend 1 because you're not getting it. So I'll go ahead and resend that. And these sequence numbers are what's used to guarantee this traffic back and forth. That's just the basics. We'll get a little bit more detailed into it later on. Port numbers. Think of port numbers as a means of listening on a particular gateway. Now, I say gateway, I'm talking about a hyperspace gateway, not a gateway in networking. Think of them as, well, you can think of them as tunnels, but then we have tunnel interfaces, so that might confuse you. Think of you actually going through a wormhole in space. If this PC one is sitting here, and I'm trying to send data over to PC2, and I want to send it out port number 23, I'm going to send this data through this nice little wormhole, bending space and time itself. Yeah, right. Going down port 23 over to this PC. Now, that's one way of looking at it. But then some people get confused with that as well, because they think that this 23 is automatically opened and so on and so on. So let's think of it as another way. I like to explain it that way because a lot of people read it as a wormhole and it get confused. I like to think of them also as this wall of doors sitting on the PC. And we got lots of doors, okay? And here's our door handle for each one of these doors. Imagine that these doors have numbers on them. Now, PC2 is going to be listening at each one of these doors. He's going to have his ear up to them. PC2 gets to find what port numbers or what doors he's allowed to listen on. So PC2 will say, I'm going to listen on door 23, on door 15, and on door 33. Okay. So these are the only doors that I'm going to be listening on, and that's it. So if PC1 sends information over to PC2, and he says, I'm going to send this information to port 25, and PC2 is not listening on the port 25, he'll never be able to open one of these doors. He's not going to open the door for that traffic to come through. And in fact, PC is going to say, I'm not listening on 25. See ya. And they'll drop the data. So these so-called port numbers, or these doors, PC2 needs to be listening on that port number in order to allow that traffic to go in. Now, if I communicate on port 23, well, that's beautiful. That's fantastic. PC2 will actually allow that traffic to come in, open this door, because he's listening on 23, and that traffic will be allowed to come in. This is the transport's job, to make sure of this transformation. So let's look at it like this. I'm going to have my application, and I'm going to build my application. In the application, I'm going to say, I want this application to be port number 1111. 1111. So what's going to happen is whenever this PC, we'll say PC1, is using this application, and that PC starts building these layers, the presentation layer, the session layer. The session layer, remember, the session layer actually goes out and tries to create this session. Once the session is created, now we're going to get to the transport layer. And the transport layer is going to define whether it's going to be UDP or TCP. If it's UDP, who cares? It's just going to send it out with the port number and be done with it. If it's TCP, we're going to set up a TCP session first to make sure we have this guaranteed traffic communication going. And once we get that TCP session set up, every time I go through and communicate to that other PC, it's going to be with port 1111, that door. So this is nice because if I have a PC sitting here, PC1, going into the switch, PC2, PC3, and I have a server sitting here. This server could be listening on port 1111, and these PCs are not. So that's nice to know, because I know if my traffic accidentally gets to PC2 or PC3, who cares? They're not listening on port 1111, so who cares? 2 and 3 would drop it, and as long as the server gets it, he'll allow the traffic to go through. He'll read the traffic, see what it's for. Whatever request that server has, he will send it back out. Now this is pretty cool. Now remember, this is just the basics. We're going to go a little bit more detailed later on. So if it's not making all sense to you, that's fine for right now. So the application would define whether he wants to do UDP traffic and TCP traffic. And this is why I'm talking about that the layers work with each other. Because the application will definitely tell the presentation how, how it needs to be presented, and the presentation will make sure that that happens. The presentation will work with the session to make sure that the session's up. And when I say they work together, really the presentation is really working with the application. Technically, it's really working with the presentation. After this part has been defined, the session will start to be created, and really the transport and the session are kind of working together. Because the session is